Run-length encoding is a very simple form of lossless data compression in which runs of data are stored as a single data value and count, rather than as the original run. This is most useful on data that contains many such runs. Consider, for example, simple graphic images such as icons, line drawings, and animations. It is not useful with files that don't have many runs as it could greatly increase the file size. ALll may also be used to refer to an early graphics file format supported by CompuServe for compressing black and white images, but was widely supplanted by their later graphics interchange format. ALll also refers to a little-used image format in Windows 3.x, with the extension ALll, which is a run-length encoded bitmap, used to compress the Windows 3.x startup screen. Typical applications of this encoding are when the source information comprises long substrings of the same character or binary digit. Example: for example, consider a screen containing plain black text on a solid white background. There will be many long runs of white pixels in the blank space, and many short runs of black pixels within the text. A hypothetical scan line, with B representing a black pixel and W representing white, might read as follows: with a run-length encoding data compression algorithm applied to the above hypothetical scan line, it can be rendered as follows: 12W1B 12W3B 24W1B 14W. This can be interpreted as a sequence of 12Ws, 1B, 12Ws, 3Bs, etc. The run-length code represents the original 67 characters in only 18. While the actual format used for the storage of images is generally binary rather than ASCII characters like this, the principle remains the same. Even binary data files can be compressed with this method. File format specifications often dictate repeated bytes in files as padding space. However, newer compression methods such as deflate often use LZ77-based algorithms, a generalization of run-length encoding that can take advantage of runs of strings of characters. Run-length encoding can be expressed in multiple ways to accommodate data properties as well as additional compression algorithms. For instance, one popular method encodes run lengths for runs of 2 or more characters only, using an escape symbol to identify runs, or using the character itself as the escape, so that any time a character appears twice it denotes a run. On the previous example, this would give the following: WW12B WW12BB3 WW24B WW14. This would be interpreted as a run of 12Ws, a B, a run of 12Ws, a run of 3Bs, etc. In data where runs are less frequent, this can significantly improve the compression rate. One other matter is the application of additional compression algorithms. Even with the runs extracted, the frequencies of different characters may be large, allowing for further compression. However, if the run lengths are written in the file in the locations where the runs occurred, the presence of these numbers interrupts the normal flow and makes it harder to compress. To overcome this, some run-length encoders separate the data and escape symbols from the run lengths, so that the two can be handled independently. For the example data, this would result in two outputs, the string www/BBWBBWWBWW, and the numbers. History and applications. Run-length encoding schemes were employed in the transmission of television signals as far back as 1967. It is particularly well suited to palette-based bitmapped images such as computer icons, and was a popular image compression method on early online services such as CompuServe before the advent of more sophisticated formats such as GIF. It does not work well at all on continuous tone images such as photographs, although JPEG uses it quite effectively on the coefficients that remain after transforming and quantizing image blocks. Common formats for run-length encoded data include TrueVision TGA, PACBits, PCX and ILBM. The ITU also describes a standard to encode run-length color for fax machines, known as T45. The standard, which is combined with other techniques into modified Huffman coding, is relatively efficient because most fax documents are generally white space, with occasional interruptions of black. See also, Kulikowski sequence, look and say sequence, comparison of graphics file formats, Guillaume coding, Burrows-Wheeler transform, run length limited, bitmap index, Forsyth or Edwards notation, which uses run length encoding for empty spaces and chess positions. Deflate. References. External links, run length encoding implemented in different programming languages.